Greetings, YouTubers, especially MadAboutHoovers YouTuber. Say that fast. What we have today is in answer to a question that MadAboutHoovers had about putting one of these mini turbine tools on the end of a hose and having it spin at different speeds, wondering what's going on with suction and airflow. So in order of highest suction to lowest suction, I have a Dyson DC-14, and right there at the end of the hose, measured with this Marshalltown gauge, runs over 110 inches of water lift. My wonderful $70 Chinese Hoover cheapie runs 80 inches of water lift right there at the end of that hose, and Kirby G5 right here at the end of this hose is running about 40 inches of water lift and probably more like 38. But anyway, we'll just call it 40 just to keep things easy to deal with. So I've got an airflow gauge here. We can look quickly at airflow. I have a suction gauge. I'm not actually going to set this up because doing the test live is very difficult. You got to use more than one hand. But how do you measure airflow? Well, you got a big hole in there. Okay, you need to not restrict the air. When you have a big open hole for the air to go through, it runs at its maximum speed. That also means that suction is at its lowest. Look at this Marshalltown gauge right here. Okay, so look at the hole here. It's this little tiny hole. And as a matter of fact, when you use it, you're supposed to block up or completely seal whatever item is you want to measure. And what happens is, when you block the airflow, you create maximum suction. And then, of course, airflow goes all the way down to zero if you get a perfect seal. So that's kind of a quick overview of airflow versus suction. So I've taken apart another one of these mini turbine tools, because they just seem to be ubiquitous. They're everywhere over here. So let's take a look at the airflow path. Put this over here. See what happens? This is open for now. Plug this in here, but what does the air hit? It hits this other turbine, and this turbine is probably blocking 80 or 90% of the airflow path that's supposed to go that way, unencumbered. Well, everything basically completely stops, and what happens is you have a suction scenario happening, because the hole right here effectively gets smaller. It gets blocked off. So I'll go and plug these things in here and let's do a few tests. I'll start out with the Dyson and then go to the Hoover and then go to the Kirby. And because I was using a program called FFT analysis, I already have the numbers telling me how fast this is spinning. So you'll be able to hear it on the video, but I'll be able to give you some real numbers with it as well. And hopefully, I'm sure there'll be a little variance, but hopefully when I connect everything up, I get as good a connection as I did before I started the camera. So be right back. Okay, I'm going to turn the DC-14 on, but before I do, this on my airflow box, well actually I don't need it on the airflow box, right here is about 77 CFM. So I'm not doing nozzle tests right now, so I'm normally used to saying, hey, at my airflow box. In this case, the nozzle CFM runs almost 80, but right here also, as I mentioned before, the water lift is like 110, so it's phenomenal. So see if you can hear how fast this spins. Alright, that was way up there, probably faster than what this thing was designed to spin at. And on my FFT analysis program, which you can download from the App Store, DC-14 runs 10,060 hertz. So this thing is spinning at that speed, and that's absolutely tremendous. I mean, that's way up there. So next, we'll go to the Hoover Tempo Wide Path. This one runs 80 inches of water lift and a little over 100 CFM at the hose. So it's got less water lift, but it's got a lot more CFM. Okay, that was pretty easy for me to hear. This was spinning definitely faster. Not that much, but some. It was a higher pitch. And on my FFT analysis program, we went from 10,060 hertz for the DC-14 to 10,600 hertz. So about 5% faster. This has a little bit less suction, but it's got a little more airflow. So go and balance that out, if you will. Now here's the biggest telling test. And I'm going to put this in over here. To be fair, I got to stretch this hose out because it's wound around a little bit. Now I'm going to turn on the G5. Okay, so on the G5, you could definitely hear this wasn't spinning anywhere near the other two machines. And my FFT analysis program says 7,100 hertz. So you're talking about a good 30, maybe even 40% less than the wonderful Hoover Tempo wide path that does fabulous with sand pickup, and certainly less than the Dyson DC-14. So MadAboutHoovers, I hope this actually explains a little bit about why your turbine tool acts differently. It's because when you try to block off the airflow, the only thing that's left, the vacuum's running, is suction. Or you could say you're creating suction, so you're trying to cut off airflow. When you do that, machines that have high suction, this machine here has very high suction, has medium airflow. This machine has like medium suction and very high airflow. So it wins, but just by a little bit. This machine has very high airflow, but very low suction. So it works, but it's like, 30 or 35% slower. So anyway, hope you enjoyed this video. I kind of put it together kind of fast, so it might not quite be up to the quality I'm normally used to, but I wanted to get your question answered as quickly as possible. So thanks for watching. Until next time, bye-bye.